So today, basically what I'm going to be talking about is why every person is a math person. And it sounds like a really broad statement, but we'll kind of explain how that works. So the first question, by raise of hands, how many of you would consider yourselves a math person? Okay, nice. So some hands, a lot of hands surprisingly, I guess because like a lot of you are math majors, so that makes sense. But I still didn't see everyone's hands. Hopefully by the end of the presentation you all can consider yourselves math people or potential math people. Okay, so math is known as like a very tricky subject. It is something that a lot of us get frustrated with. And by another raise of hands, how many of you have ever found yourself upset or frustrated by a math problem? Basically every hand. Yeah, it's a tricky subject. And a lot of it is because of experiences like this. Some of it is because maybe we haven't had great teachers. Maybe for some of us, like myself, it just takes us a bit longer to grasp certain concepts, and that's okay. But at the end of the day, everyone can ultimately do math. And that's kind of what I want to tell you guys about today. So you might be thinking, okay, like, why is this girl who's already in math, like why is she telling me that like every person's a math person? If she's in math, she's probably already a math person. And honestly, I don't consider myself a math person. So this is kind of my story. So this setting might look familiar to a lot of you. It is a high school classroom. And I'm not sure how looking at it makes you guys feel, but for me, when I look at it, my stomach drops. For me, high school was not a very pleasant experience. It was very stressful. I didn't like it, especially math classrooms. For me, when I was planning out my high school courses, I planned them all out at the beginning of grade 10 because you need to meet certain credit requirements, certain prerequisites, all of that. I planned it out so that in grade 12, I wouldn't have to take any math courses. And I really, really dreaded every day when I got to school. If I looked at my schedule and I saw math on there, my heart just dropped. I really, really dreaded the class. This was me. I struggled so much in all of my math classes, and it sounds like I'm being dramatic. I'm really not, because time and time again, I would be in class, I'd be looking at my assignments, my quiz, my group work, whatever it was, and I would stare at the question. I just didn't know what was going on. I would have gone to the lectures, I did all the homework, so I was like, why am I not getting this? And then I would start to feel like the room was closing in on me. I would start to feel hot, sweaty. My brain would shut off, but simultaneously my thoughts were racing. And then before I knew it, I was crying and having a panic attack. And after each one, normally they ended by me getting escorted to the front office of the school. And then after one too many panic attacks, I found myself in the guidance counselor's office, which is a super fun meeting to have. And I went to a university preparatory school. So basically it's not your typical public school. And the guidance counselor actually told me that maybe I should consider going to a different school. And maybe this one wasn't for me. More of the story is I ended up actually graduating from that school. So I stayed, but it definitely wasn't easy. And now, with all of that being said, I am somehow a double major in applied mathematics and computer science. And I consider computer science like a glorified math degree. So basically, like, just a lot of math. And if you had told me this when I was in high school, I would have laughed in your face. So we're gonna come back to this slide in a little bit. In the meantime, I want to talk about how such a drastic change happened. How did I go from having panic attacks when I was in high school to being a double major in two subjects very heavy in math? Basically in grade 11, I had a really great math teacher, and he basically showed me how to think mathematically. He showed me that mathematical thinking is a skill that you acquire. Some people are born with more mathematical thinking abilities than others, but at the end of the day, it's super possible for everyone to have it. So I'm going to explain how just such a drastic change happens through a different example. So I'm going to ask you all a question and get you to raise your hands. It's a very serious question, so please answer honestly. How many of you were born out of the womb being an Olympic gymnast? I don't see any hands. How many of you know someone that was born out of the womb an Olympic gymnast? No one. Because they don't exist. But somehow we have so many Olympic gymnasts. And how does that happen? When you're born, you're like a potato, you're a vegetable, you can't do anything. And then you learn how to crawl, you learn how to sit up, you learn how to walk, then to run, and your parents enroll you in your first gymnastics class. You're like, okay, I can like skip, I can stretch, I can do all these fun things. Then you progress, you work hard, you learn how to do a cartwheel, you learn how to do a somersault, maybe a backflip if you're really good at it, and then you keep training, you work really hard, time, dedication, effort, repetition, and then that's how people become Olympic gold medalists. This year is Simone Biles, and a lot of you probably know her. She's a very famous Olympic gold medalist, and I promise you she was not born an Olympic gold medalist. She did it because of hard work and determination, and because she kept trying. So all of that is to say that we're all capable of doing things because you have to learn everything you do in life. And the reason because of that is because of this cool thing called neuroplasticity. Essentially, neuroplasticity is the brain's ability to reorganize synaptic changes. And what does that mean? Because that's a lot of big words. So basically, here we have this diagram. We're gonna look at the bottom one. This is a neuron. Our brain and body are made of neurons. That's how we move, that's how we talk, that's how we do anything in life. Basically, our neurons, electric signals are sent through them. You see this bottom one, the electric signal, the blue dot, is moving really slowly and it doesn't even reach the end of the neuron. That is what your neural pathways look like when you first learn a skill. Any skill, really. Even when you're learning to talk, to walk, when you're learning a math problem. And then, as you do it over and over and over, our neurons do this really cool thing and they build a sheet of myelin across them. And myelin basically allows the electrical charges to jump faster across the neurons. And as you can see at the top one with the myelin around it, it's reaching the end of the neuron and it's going a lot faster. That's why when you're reviewing for your classes and you're doing flashcards, every time you review them, that myelin is building and each time you can recall it faster and easier. So the point is that every person can be a math person if you work hard enough, if you put in the time, put in the effort, put in the repetition. And I'd like to extend this to people who are not even interested in math and say that you are capable of quite literally almost anything you set your mind to. Because everything is essentially a learned skill at the end of the day. So how do we use neuroplasticity to our advantage? I'm going to use the example of multiplication. So you show up, first grade, you're in class, and then your teacher says, okay guys, we're learning this thing called multiplication. And you're like, multiplication? Like, what's that? And then she says, okay, like it's basically, we're gonna say you know these things called numbers. If you have 3 groups of 5 things, that means you're gonna have 15 things. And your little brain just can't grasp your head around it. Then your teacher gives you lots of worksheets, repetition, and you give yourself specific focus towards that subject. I don't know about you guys, but when I was in elementary school, we had these things called Mad Minutes, where the teacher would give us worksheets and then put like 60 seconds on the timer and you answer as many questions as you can in that minute. That is an example of what step 2 looks like. And then you don't just learn multiplication once in grade 1 and then never use it again. You cover it again in 2nd grade, 3rd grade, 4th grade, and then end up using that skill virtually for the rest of your life. And that is how you know how to do multiplication. And then connecting this all back to neuroplasticity. You know how to do multiplication, you know your multiplication tables, and just because you haven't seen a multiplication question before doesn't mean you can't do it. For example, if I put it on the board, it's a long multiplication question, definitely. But if I gave you guys a pen, a paper, and quite a bit of time, you guys would be able to figure it out because you know what 3 times 6 is. You know what 2 times 6 is. You can do all the small steps. You have the tools to solve a problem, even if you haven't seen it before. And the same thing works like when you're solving mathematical proofs, you look at a question, you're like, I don't know how to solve this. But you know the definitions, and you can unwind them, and that's how you end up solving a proof. That is essentially the fundamentals of mathematical thinking and why everyone is capable of it. We'll use another example and show how you can build up to something like a proof. So you're in elementary school, they tell you there's these cool things called numbers. And these numbers, you can add them together. And you're like, okay, this is really cool. Then they're like, okay, now there's these things called fractions. We're gonna add fractions together. And then we're gonna figure out what the lowest common denominator is. And you're like, okay, I got the hang of this. And then they say, okay, we know addition, subtraction, different operations. Now here's these things called variables. We're gonna have input and output and call it a function. Once you have functions, you reach the point of calculus, where you use the definition of a function to learn what a limit is. And then that becomes a derivative. And once you know derivatives, the opposite is just an integral. You learn how to do cool things with these derivatives, these integrals, all of those things. Then, if you're in university and you're taking math, then you learn what a partial derivative is. You learn, maybe some of you are familiar with the Cauchy-Riemann equations. That all builds up on top of just the simple addition that I talked about at the beginning. And then you work your way up to something like a proof, which seems super, super daunting, but I think for all of us here in this room, if 5, maybe even 6 years ago you told us you'd be able to do a proof, you probably would be like, no. I didn't even really know what a proof was in high school, and here I am doing them. So that's the fundamentals of mathematical thinking and how no one was actually born knowing how to do a proof. We all learned it over time. But beyond math, there's some other really cool applications of neuroplasticity that apply to basically everyone. How many of you are familiar with the concept of CBT, or cognitive behavioral therapy? Okay, lots of hands, good. So cognitive behavioral therapy is essentially, for those of you that aren't familiar with it, it boils down in its most simplest form to replacing negative thought patterns with positive thought patterns. So if you think something negative, you catch yourself, and then you're like, for example, if your car breaks down, and then you're on the side of the highway, and maybe your first negative thought pattern is like, oh my goodness, my day's ruined, I can't do anything, and then you sit on the side of the road crying. If you reflect on that situation, you can instead say, okay, the car's broken down, maybe let's call a tow truck. Let me call a friend, let me get some help. That's a more positive, constructive way to think about a situation when you're in dire need. And every time you do CBT, every time you replace a negative thought with a positive thought, you are building the myelin on the neural pathway for the positive thought, and neural pathways are use and disuse. So you're using the negative one less, and eventually that's going to atrophy and wither away. And same thing works with affirmations. And some people think they're really silly, and honestly I have for a long time, where you just stand in front of your mirror and you say, I'm strong, and I'm confident, and I can do this, and I'm amazing. And it's like, okay, if I look in a mirror and I say I'm strong, that doesn't make me strong. Like, that's not how it works. But when you say you're strong, you build that pathway in your brain. Because you think you're strong, you're more likely to do things that strong people would do. You're more likely to go to the gym. You're more likely to take on harder things. You're more likely to feel like you're capable of different opportunities that you didn't feel capable of before. And it becomes a self-fulfilling prophecy, and you end up manifesting that strength just by saying in a mirror, I'm strong. So that's a really cool application of neuroplasticity, and I use that in my day-to-day. Okay, so I told you we would come back to this slide. So, in university, I have done so much that I never, ever, ever thought I would do. And the one example I want to highlight specifically is being Vice President of Finance of Speak Western. So I signed up for that, and I was like, I'm going to be like in finance, I can do like the Excel sheets, like this is super, super cool. And then I'm going throughout the school year, and I'm like, I need to get sponsorships for this club. Send some cold emails, doesn't work. Talk to the president, we decide that we need to do cold calls. Anyone that knows me knows I have a lot of social anxiety. If we go to a store and the thing I want is not there, I don't want to ask the person who's there. A lot of times I would rather leave than ask them. If it's time to order food, I will ask whoever I'm with to order it for me. I don't like talking to people or talking to strangers in those kinds of settings. So a cold call was really daunting. But I told myself that, okay, neuroplasticity, neural pathways, like just because I feel this fear now doesn't mean that I can't rewire my brain. I said, if I avoid this now, I'm strengthening that pathway that tells me that I can't be social, I can't talk to people. So I said, okay, I'm gonna pick up that phone, and I'm gonna build a new neural pathway that tells me that I can talk to people, that I can be confident, that I can acquire sponsorships. So I made a list of a bunch of small businesses in London. I got all their phone numbers, and one by one, I picked up the phone. I said, hi, I'm Erina, I'm from Speak Western. We're looking for sponsorships. Is that something you guys do? And in less than 2 months, I acquired over $1,500 of sponsorships for the club just by picking up the phone and calling, because I knew the power of neural pathways and neuroplasticity. And all of these other things on here, these are things that I did not know how to do. I did not know how to be a president of a club. Like, I remember at the end of my first year being president, I was talking to my exec team, and I told them, I was like, I know I seemed like I knew what I was doing, but it was quite literally the blind leading the blind. But I figured it out, and no one kind of knew that I wasn't sure what I was doing. I started Math Bridge, which was a nonprofit. I've never run a nonprofit before. Do I really know what I'm doing? No, but I figure it out as I go, and I try to believe in myself. And I published a book this summer, and I didn't know the first thing about publishing a book. But then I told myself that, you know what, even though I don't know how to do it, I will figure it out. And I figured it out, and I did it. And if you believe in yourself, I think that you can accomplish a lot more than you think you can. And one trait, funnily enough, that I think a lot of successful people have is just a little bit of delusional confidence. Just a little bit of it. And you'd be surprised with what you can accomplish. So I'm telling you all this, but like, what do you do with it? My advice to you is to consider trying something new. Maybe you're looking for summer internships, and you're thinking, oh my goodness, I don't meet the qualifications for any of these. Apply for the job. Who cares? Maybe your resume will fall into the hands of that one recruiter that doesn't care that you don't know at Microsoft Excel or Power BI, and they get your interview, you interview well, and you get the job. Maybe you've always wanted to know how to code, but you have no idea how to do it, where to start. This weekend, go home, watch a YouTube video. How to download Python. Maybe take an introductory coding course. You think the best computer scientists knew how to code, like, as a kid? No, they learned it step by step, and they picked it up, and you can do the same thing. So start the business, publish the book, apply for the job, learn how to code, whatever it is, do it. Because everything at the end of the day is a skill. And even if you're like, I'm not naturally gifted at this, I wasn't naturally gifted at math. But I will say 9 times out of 10, hard work always beats talent. You can be as talented as you want, you can be the best athlete naturally in the world. If you don't put in the work, someone who puts in the work is going to become the gold medalist, and you won't. So that would be my advice. And even though in junior high, I sat in a classroom having panic attacks, and I really associated math classrooms with a lot of pain and frustration and upset. Last year, I was able to visit a high school classroom and tell them my story, and tell them how to incorporate math into their degree. The very talk I'm giving you right now about the importance of neuroplasticity, about trying new things. And my point is that if I can do it, anyone can. Thank you.